Welcome to another edition of CSEC Chemistry Simplified. We will continue to look at acids, bases, and salts. And I am Sir Damien LaRose. Our focus in this lesson will be on acids in living systems, reactions of bases with ammonium salts, and uses and dangers of salts. As we begin with acids in living systems, we see that living systems constitute all organisms from the plant and animal kingdoms and humans. And so, as a little recap, remember that anything that tastes sour would be an acid. Here, we begin with citrus and fruits. And our citrus would be lime, lemon, orange, tangerine. We can have mangoes as one of our fruit. We move on to tea leaves. Yes, we have acids in tea leaves. And we even have an acid in bee sting. So while you are wondering just why is it that it is hurting so much, it is because the acid in the bee sting is working on your cells and it gives a nasty burning sensation. To continue, we also have acid in the walls of our stomach. And sometimes, if you ever brought up some food, you would notice that there's a burning sensation and it also smells kind of sour. That is because we have an acid, a very strong acid, that is hydrochloric acid. When we get to our muscles, if we have an exercise and we are doing a lot of work in that exercise, we would normally feel a burning sensation in our muscles. And that is because the oxygen in our muscles has become depleted. In the bee sting, we also have an acid there, just like the ant sting. We also have acids there. Just to let us know what type of acid is in which specific living system, notice that we have citric acid with the formula COHCH2 to COOH3. And we can find this in citrus fruit. Okay? Citric acid is in citrus fruit. We have tartaric acid, CHOHCOOH2, and we find that in tea leaves. If you notice that we have it being a solid, and that is because citric acid and tartaric acid are both solid in nature. Ethanoic acid, while we don't have this in any living system, we put it here because you would normally consume ethanoic acid. Sometimes we put it in our salad, or if we have to make a pickle, Christmas time, we would normally do pickled pork, or we can also do pickled garlic or pickled onion, and so we consume ethanoic acid. It is a liquid, and it is the acid that we put in vinegar. Hydrochloric acid, from the diagram, we notice that it is found in the walls of the stomach. Ascorbic acid, we know that to be vitamin C, C6H8O6, and this is found in fruits and in citrus. Lactic acid, CH3, CHO, HCOOH, which is found in muscles during heavy exercise, or we can say during strenuous work. Formic acid, HCOOH, or CH2O2. We find this in insect sting, such as the ant and the bee. So here we are with acids in living systems. We will now be looking at reactions of bases with ammonium salts. Ammonium salts are decomposed when mixed with a strong base to produce ammonia gas. Strong bases are those that constitute sodium hydroxide and potassium hydroxide, or we can say the hydroxides of the group 1 metals. If you should go to lithium hydroxide, which is also a group 1 metal, that would be a strong base. Ammonium salts are chemicals which contain the NH4 plus ion and a negative ion. For instance, we have ammonium chloride, ammonium nitrate, or ammonium sulfate. They are all ammonium salts. The Cl minus would be the negative ion, NO3 minus the negative ion, and SO4 2 minus would be the negative ion that is in ammonium sulfate. And so for our general equation, we will be using sodium hydroxide as the strong base plus ammonium chloride to give us sodium chloride, ammonia gas, and water. Notice that we will be forming the corresponding salt. Ammonia gas is liberated and we have water being there. For the symbol equation, NaOH plus NH4Cl would give us NaCl, NH3, that's a gas, and it will be liberated, and H2O in the liquid form. Continuing, we have sodium hydroxide again plus ammonium sulfate to give us sodium sulfate plus ammonia and water. For our equation, we will have NaOH plus NH4 to SO4 to give us sodium sulfate, Na2SO4 plus NH3 ammonia and water. And for a final reaction, we continuing to use sodium hydroxide plus ammonium nitrate to give us sodium nitrate and ammonia and water. The symbol equation would give NaOH plus NH4 NH3 to give us NaNO3, the salt, NH3 ammonia and water. To verify the gas that is given off, the ammonia is readily detected by its pungent odor, or we say our strong smell, and by turning damp red litmus paper blue. If you want to know where you get ammonia from, for you students, all you need to do is to pass around by your washroom in your school, and that strong smell that you get, that would be ammonia. Ammonia gas is colorless, but it really hits our nose. The ionic equation for all of the reactions, basically, it is NH4 plus, that is the ammonium ion, plus OH minus, that is the hydroxide aspect, then to give us H2O liquid plus NH3 gas. Once again, the ionic equation would be NH4 plus OH minus to give us H2O, which is water, and NH3 ammonia gas. We will now be looking at uses of salts. Salts are widely used in various industries, in our homes, and society. Commonly, what we will begin with is sodium chloride, which we know to be common salt, NaCl, and in our homes it is used to flavor food, it is used as an antiseptic, and as a cleaning agent. Potassium chloride, potassium nitrate, and sodium benzoate, they are all used as food preservatives. Note that sodium chloride is also used as a food preservative, but is not used as much as potassium chloride, potassium nitrate, and sodium benzoate. And just in case, KCl, this would be potassium chloride, KNO3, potassium nitrate, C7H5NaO2, that would be sodium benzoate, and they are generally used as food preservatives. Sodium fluoride, NaF, used in our toothpaste, what we use to brush up our teeth, and that would give us the fluoride to strengthen our enamel. Silver chloride and silver bromide, AgCl, silver chloride, and AgBr, silver bromide, they are used to make photographic films. Today we use the digital camera. Many years ago, there was no digital camera, and we used to use photographic films in those times. Some photographic films are still used today. Ammonium sulfate, ammonium nitrate, potassium dihydrogen phosphate, what we call potash. So NH4, 2, SO4, ammonium sulfate, NH4, NO3, ammonium nitrate, and KH2PO4, potassium dihydrogen phosphate. They are used in agriculture as fertilizers. The NH4, that is what would produce the ammonia. NH3 would give the nitrate, and the PO4 would give the potash that is used for proper plant growth. Calcium sulfate, we know it as plaster Paris, but actually we would call it plaster of Paris. It is used in medicinal purposes, and that whiting, as we would normally say, cast, your hand cast. If you want to speak perfect English, we will say the cast over our hand, that white substance that is normally used whenever we have a fractured bone or a sprained joint. It assists in healing of bones and joints. That is calcium sulfate, plaster of Paris, or as we would say, plaster Paris. Magnesium sulfate, Epsom salts, that is MgSO4, it is used as a laxative. So if someone would like to have a little bit clean out, we would give them some magnesium sulfate to send them to the washroom 2 or 3 times for the day, and that would ensure that their colon is cleaned out. Just by comparison, to let us see how salts are used, we have in the red, which is at 12%, in water conditioning. In the yellow, 6% food grade salt, that is what we eat. 6% in agriculture. 7%, 8% in highway de-icing, and this is in the areas where they would have snow. Salt is used to remove the ice from the highway, and 68% is in industrial chemicals. So salts are used widely in industry to produce other chemicals. We now look at the dangers of salt. For instance, when we get to sodium chloride, while we use it to flavor our food, and we also use it as a preservative, overconsumption can lead to possible high blood pressure. Remember, this overconsumption can lead to possible high blood pressure. It does not mean directly if you do not have high blood pressure. If you consume a little bit extra sodium chloride, you are going to have high blood pressure. It is simply saying it can lead to possibly high blood pressure. Sodium nitrate is implicated in causing brain damage in infants and also suspected to be carcinogenic. So we have to be careful with those foods that we see have a lot of sodium nitrate, because they can cause us to have cancer. It is suspected to be carcinogenic, which means it is cancer causing. And for mothers who are carrying babies in their tummy, be careful when you go to the store, look at the label to see if it has any sodium nitrate for whichever food you are purchasing, because it can cause brain damage in the infants or that which you are carrying. Our key points to remember in this lesson would be that acids are found in fruits and citrus, things such as orange, cherries, and we can even go to mangoes. Acids are found in insect sting, such as the ant and bees. In the presence of a strong base, ammonium salt decomposes to give another salt, ammonia, and water. Salts are used as preservatives for flavoring food, in agriculture, for industrial purposes, and in medicine. This brings us to the close of another session of CSEC Chemistry Simplified. Join us again as we continue in our lesson with acid, bases, and salts.